Welcome back to new session. This is your trainer and PMP coach Anand. This session is continuation of quality management knowledge area. In this session, you will learn plan quality management process. This is where you will learn to create quality management plan. Learning objectives are: we will start with overview to understand why quality planning is critical. We'll go through plan quality management definition, input, tool, techniques and output. We'll talk about test and inspection planning, cost of quality and cost benefit analysis, and finally we'll go into details of what constitutes quality management plan. And of course, a quick review at the end. Let's have a quick look at quality management processes. Plan quality management, which is a part of planning process group. This is about creating quality management plan. And we are going to learn this in the current session. Next is manage quality, which is part of executing process group. This is about quality assurance. This is where we will ensure what was planned and what is executed is correct and it is giving us expected results. And final process is control quality, which is a part of monitoring and controlling process group. This is about executing quality activities like testing and inspection. This is about verifying product or service whether it is developed as per requirements or not. Let's understand why do we need quality planning through an example. Imagine you are working on a construction project. You are halfway through a construction of the building. Client tests the concrete strength and says concrete does not meet stated requirements. Client rejects the deliverable. This is a big issue for a project manager as you need to get business acceptance to move forward. And business is in no mood to give you the acceptance. How you will manage this situation? Whose fault is this? Why this happened? If your project don't have a documented quality management plan and quality requirements document, then no one can save you. However, if you have a documented and approved quality requirements and quality management plan, then it will be easy to analyze the situation and find the root cause of the issue. You also can find who is accountable for acceptance in such a situation. And in case if you are lucky and after analyzing you find the strength of concrete is within agreed limit, then customer is liable to accept it. This is where quality planning will help you. Remember, planning is an iterative process. You plan, implement, measure, react and improve the process based upon lesson learned and the cycle continues. During quality planning, project manager will focus on finding existing quality standards and practices which can be applied to current project. If required, he may ask quality team to create additional project specific practices and standards. Sometimes it can be a tailoring of a process. This is especially required if you are doing one of the kind of project, your first time such a project is getting executed within an organization. Determine work to meet the standard. On some projects, you may use third-party quality audit teams to ensure quality of work. Also, determine how you will measure, what are the measurement criteria to ensure deliverables meet the agreed standard. Project manager may perform cost-benefit analysis and determine cost of quality. There has to be balance. If the cost of quality is too high, product may not give required ROI. During quality planning, project manager has to balance the need of a quality with the scope, cost, time, risk, resources and customer satisfaction. Project manager should ensure there is a quality improvement plan and quality management plan so that overall quality of the project and product is managed from inception of the project till closure of the project. Let's look at planned quality management definition. It is a process of identifying quality requirements and standards for project and its deliverables and documenting how project will demonstrate compliance with the quality requirement. This is where quality approach is agreed. It's a planning process. Quality planning can be done based upon the quality requirements. We already learned about collect requirements under scope management knowledge area. Collect requirement process help you to collect all sort of requirements including quality requirement. Planned quality management provide guidance and direction on how quality will be managed and validated throughout the project. Planned quality management process has 6 inputs, 7 tools and techniques, and 5 outputs. Let's look into them in detail. Planned quality management inputs are project charter, project management plan, project documents, enterprise environmental factors, organizational process assets. Project charter contains the high-level project description and the product characteristics, which are the technical requirements. It may also contain any requirement for a final product to be approved by the customer as a part of validate scope process. Project management plan. Some of the subsidiary plans that we will use from project management plan are requirements management plan, which explains how the requirement will be identified, analyzed, and managed throughout the project. Scope baseline. Approved project scope statement, work breakdown structure, and WBS dictionary put together is called as scope baseline. The requirements are broken down into the deliverables in the project scope statement, and these in turn are broken down into work packages in the work breakdown structure. And finally, WBS dictionary provides details like resources, material, cost of each work package. Risk management plan. Risk of defects need to be considered while determining cost of quality. Risk management plan may allow certain level of risk of defects based upon comparison of cost of doing quality control measure with cost of not doing them. Stakeholder management plan. It documents stakeholder needs and expectations that contribute to the quality requirements. Project documents, which includes assumption log, which is output of developed project charter process. It contains assumption and constraints regarding quality requirements. Requirements documentation, including requirement traceability matrix. This may include project and product quality requirements as well as tests required to verify those requirements. Risk register. It may contain information on the threats and opportunities that may impact quality requirements. Stakeholder register helps identify stakeholders who have particular interest or impact on the quality requirements. Enterprise environmental factors that may influence the quality requirement for the project are government agency regulations regarding health and safety, rules, standards, and guidelines specific to application area. So this depends on industries to industry for which you are developing a project. Working or operating conditions. OPAs that can be used as input are organizational quality policies, procedures, and guidelines, historical database and lesson learned, and quality related templates like check sheets. Planned quality management has a big list of tools and techniques. Most of these tools and techniques are also used in managed quality as well as in a quality control process. So what are the tools and techniques? Expert judgment, data gathering, data analysis, decision making, data representation, test and inspection planning, meetings. Expert judgment. Subject matter experts are always required while creating any management plan. In this case, experts are required with expertise in anything to do with quality, which includes quality planning and improvements, making sure that there is a process in place to improve quality such as Six Sigma. Quality assurance. This is where you ensure that the quality processes are done correctly. Quality control. knowledge about quality control to ensure testing is done properly and quality outcome fulfills the project criteria, as well as experts with the knowledge of various quality systems. Data gathering. Some of the data gathering techniques used to gather data regarding quality are benchmarking, brainstorming, and interviews. Benchmarking is the comparison of actual or planned practices such as processes and operations to those of comparable organization. Benchmarking can be done between two technologies or two systems, materials, standards like a green building standards, and between two projects for a cost performance and or schedule performance. Let's take an example. If you are manufacturing a new phone and expect it to be compatible with IP65, a standard that defines how strong is your mobile like shockproof, waterproof, etc., then you will simply include this requirement in quality requirements. You don't need to worry about providing detailed requirements. Benchmarking helps to identify best practices, generate ideas for improvements, and provide a basis for measuring performance. The organization or standard compared during the benchmarking can be internal or external. Brainstorming. It is a general data gathering and creativity technique that can be used to collect multiple ideas in a short period of time from team members, stakeholders, and subject matter experts. Of course, in this case, ideas are more focused on quality. Interviews. Interviews are done by having members of the project team to do individual interviews of experts and or stakeholders in order to get their views on appropriate quality standards for the project. Data analysis techniques used are cost-benefit analysis and cost of quality. Let's look in detail. Essentially, cost of quality and cost-benefit analysis are doing the same thing. They make sure that the planned quality activities are cost-effective. In other words, the cost of prevention and appraisal of defects need to be less than that of cost of non-conformance. Cost of quality is divided into two areas: cost of conformance and cost of non-conformance. Cost of conformance includes prevention cost, which means cost of building quality product. For example, training, process documentation, testing equipments, and time required to do things. Appraisal cost, which means cost of assessing quality of the product. For example, conducting tests, destructive testing, inspecting deliverables, etc. Overall, cost of conformance includes money spent during the project to avoid the failures. Cost of non-conformance includes internal failure cost, which means cost of failure found by the project team. For example, it can be rework or scrap. External failure cost means cost of failure found by the customer or external party. Example includes product recall, liabilities, warranty work, loss of business, credibility. Overall, cost of non-conformance include money spent during and after the project because of failures. Cost-benefit analysis. It is financial analysis tool used to determine the benefits provided by project against its quality-related cost. Project manager has to compare cost of quality versus benefits. Benefits could be less rework, higher productivity, lower cost, increased stakeholder satisfaction. The primary cost of meeting quality requirement is expenses associated with the quality management activities. Data representation. Following data representation techniques can be used: flowcharts, logical data model, matrix diagram, mind mapping. Flowcharts, also called as process maps. It's like a 49 project management processes. Output from one or more process are used as input in another process. which then apply tools and techniques to create new outputs. Again, these outputs are used as input in other processes. They are useful in understanding and estimating the cost of quality for a process. Flowcharts can be used in quality planning, to estimate cost of quality, process communication, and to analyze quality problem. They are sometimes referred as SIPOC diagrams, SIPOC, supplier, input, process, output, and customers. Matrix diagram. It shows the relationship between factors, causes, and objectives listed in the rows and columns of the matrix. They are useful in identifying the key quality matrices for a project. It provides a compact way of representing many-to-many relationship of varying strength. For example, if you want to establish many-to-many relationship between values in two columns, as you can see in the picture, you can draw multiple lines representing many-to-many relationship. However, this looks little messy. The clean way is to keep the first column as it is and put the values from second column onwards as a heading in subsequent columns, as shown in the picture, and then mark the relationship between both. Let's look at one more example about defects classification using matrix diagram. The matrix diagram on the screen shows list of defects and various software components impacted by these defects. First column shows list of defects and subsequent column headings are various software modules as shown in the picture. One defect may impact one or multiple modules and accordingly it will be marked in the matrix diagram. Next is mind mapping. Ideas created through brainstorming are consolidated into single map to reflect commonality and differences. This can lead to generation of new ideas. For example, a quality standard is put in the center of a blank page and ideas that are associated with it are put around the center. It helps with the rapid gathering of ideas, quality requirement, constraint, dependencies, and to understand the relationship. Mind mapping is used for thinking through a complex problem, summarizing information and note-taking, consolidating information from different research sources and linking them together, and presenting information showing overall structure of the subject you are targeting. Next important tool and technique is test and inspection planning. During the planning phase, project manager and the team determine how to test or inspect the product, deliverable or service to meet the stakeholders' need and expectations. How to meet the goal for the product's quality, performance and reliability. One of the cost of conformance is the cost of appraisal of whether a defect exists in the product or not, namely the cost of testing or inspecting that product. The project team need to determine how to test or inspect the product as well as how often to do the test or inspection. For example, in software project, you may have alpha, beta testing or system integration testing, which is called as SIT, or UAT, which is user acceptance testing. In construction project, strength test, material test. Manufacturing projects may have inspection. You may decide on the sample for inspection. In engineering, you have field and non-destructive test. Maybe in car manufacturing companies, you use car crash test apart from other simulations that are used to verify different parts of a car. So all these are your test and inspection planning. Decision making. As you know, some tool and technique works independently and some works with other tool and techniques. Decision making can be used along with cost of quality, meeting, test and inspection, planning, tools and techniques. For example, how decisions are made during meetings with the subject matter experts and/or project team members. Prioritization matrix is a decision-making tool, also called as criteria matrix. It can be used when deciding which design features are critical to the quality, or in making a decision related to any set of criteria like the frequency, severity, etc. Prioritization matrices takes various alternatives developed during the brainstorming and interviews and rank them based on the criteria that are decided upfront in the quality management plan. Outputs are quality management plan, quality matrices, project management plan update, project document updates. Quality management plan explains how organizations' quality policies will be implemented and how to conduct quality management processes, that is, manage quality and control quality. Following details may be included in quality management plan. The quality standards to be used on the project, what are the quality objectives and how they will be achieved, the quality roles and responsibilities, who will conduct the quality assurance and/or quality control activities, is there a quality department in the organization, or if you are hiring third party to perform periodic quality audits. Project deliverables subject to quality control, project processes subject to quality control. The quality control and quality management activities planned for the project, quality tools to be used on the project, and finally, procedures for dealing with non-conformance such as defect repair and corrective actions, as well as procedures for continuous improvement. So all this information will be a part of your quality management plan. Quality matrices. Quality matrices describe a project or product attributes and how the control quality will verify the compliance to it. They are used to directly translate customer needs into acceptable performance measure in both products as well as in processes. For example, number of defects identified per day, error found per 1,000 line of code in software projects, percentage of tasks completed on time or percentage of tasks delayed, customer satisfaction scores. In manufacturing, it might be machine failure rate per month, a total downtime per month. The matrices and tolerance level for variation is set in the quality plan, and the control quality process need to verify compliance with these quality matrices. Project management plan updates. Apart from creation of quality management plan, there are other project management plan components which are updated as a result of this process. Scope baseline. The WBS may get updated with the addition of quality management activities, and the WBS dictionary may record quality requirements. Risk management plan. Agreed quality management approach from quality management plan may lead to changes to the risk management on the project. These changes will be updated within risk management plan. Project document updates. Lesson learned register may be updated with any challenges encountered during quality planning. Quality requirements are recorded in the requirements traceability matrix. New risks are identified and are updated inside risk register. Stakeholder register are updated with the details of interest or influence of existing or new stakeholders on the quality issues. Good job! You have completed planned quality management process. Let's do a quick review. We started with overview to understand why quality planning is so critical. We talked about planned quality management definition, gone through input tool techniques and outputs, learned about what do you mean by test and inspection planning. We talked about cost of quality, cost benefit analysis, and then we gone into details of quality management plan and learned quality planning is a continuous process. Thank you.